In this section we're talking about limits, and we're evaluating limits using the graph. You'll see that I have graphs listed for you. You can find blank copies of this graph inside your Canvas, of these graphs rather, inside your Canvas course. There are three different things I want to point out, and I've already written the rules out for you. If you have a minus, it looks like it's in the exponent position, but that's not really what it means. But if you have a minus raised above the limit value, that means you're looking as x approaches 0, in this case, from the left. If you have a plus, that means you're looking at the right side of that value. And if it doesn't have a raised expression over the limit value, that means that you're looking at both sides. In my first graph, I ask you to find the limit as x approaches -2. That's just going to be your y value. So you see on the graph where I've already shaded it, x is -2, where you see the red point. The y value at that point is 3. So this limit right here would just be 3. Basically, for most cases, you're just looking at the y value at that particular point. Now, something funny happens at 0 for this particular graph. I ask you three different questions regarding 0. I ask you 0 from the left, because of this little minus right here. I ask you 0 from the right. Let me change those colors just a second so that they match my colors on the left. That would be right. All right, here we go. I'll get it right. Now then, let's try this one more time. Okay, so from the left, it's got a little minus right here. We're going to be looking at 0 from the left. The next one has a little plus here, so that's going to be looking at 0 from the right side. And the last one doesn't have one, a sign lifted up high, so that means we'll be looking at both sides. Now you'll see the reason that this graph is different at 0 is because the graph doesn't meet at 0. Two different things happen at 0, and that's what makes it so funny. So let's look at this first one. I ask you, right here, here's where I am, I ask you to evaluate the limit as x approaches 0 from the left. Okay, this is my left side over here. So as I'm getting closer and closer and closer and closer and closer to 0 from the left, here's where my point goes, and that would be 2. So the answer to that one is 2. Okay, let's look at the other side. I ask you to evaluate the limit as x goes to 0 from the right. So here's my right side over here, right side of 0. As I get closer and closer and closer to 0 from this side, getting closer and closer and closer, here's where my graph finishes. That's the y value 3. Now the last part says let's analyze it from both sides. So if I come from the left, I'm going to 2. If I come from the right, I'm going to 3. Those do not match. So that means this limit does not exist because they do not match. They do not match from the left and right at 0. Okay, so that's what that part looks like. Now I kind of threw a couple of extra ones in there. You will see evaluate f of 0 and evaluate f of 3. All that is point values. That's it. So for this f of 0, I want to know what is y when x is 0. Well, here's where x is 0. There's actually two different points. One is an open circle and one is a closed circle. So you want to take the open circle because that's where the function actually exists. So if I said what is f of 0, basically I'm saying what point is given there, and that would be the point 0, 2. So this value right here would be 2. The other question I asked you was f of 3. At 3 you see two different points, one open, one closed. I want to talk about the closed one. The coordinates of this light blue point are 3, 3. So x is 3 and y is 3. And that's how you evaluate the function values, and you'll see that in your homework as well. Okay, so that's your first graph. Let's talk about the second graph. It's special because it's a asymptote. So for this particular graph, again, I'm asking you from the left and the right, and then just straight on. Okay, this little minus right here means I'm approaching 2 from the left. Now I want to make sure you see that's a positive 2, but the little minus doesn't change the value of the 2, it just tells you which side of 2 you're on. So for this minus right here, that means I'm on the left side of 2. Okay, the next one you see right here is a plus. That means I'm going to be on the right side of 2. And then again, right here we'll be looking at both sides of 2 and what happens. Okay, so here's 2. This dotted line right here is 2. For the first one, I want to see what happens on the left side of 2. Here's the left side. As I approach 2, I'm going to start here at 0. Here's where x is 0. I'm going to 1, 1.5, 1.9, 1.99999, and so forth. And I notice that it's going down indefinitely. Well, down indefinitely represents negative infinity. So this is going down, so it would be going to negative infinity. Okay, on the other side, I asked you what happens on the right side of 2. That's the 3, 4, 5 side of 2. So if I start over here, and I'm going, I'm like to 4 and 3 and 2.5 and 2.1 and 2.01 and so forth. I'm getting closer and closer and closer to 2. I see that my graph is going up. So since it's going up, that means it's going to positive infinity indefinitely. Now what I notice about both sides is this. One's going down, one's going up, so that lets you know they do not meet. So since they do not meet, my answer is does not exist. They do not meet.